Welcome to AI Frontiers. Today marks a revolutionary day in computer vision research. December 27, 2025, brought us 17 groundbreaking papers that collectively represent a quantum leap in how machines perceive and understand our visual world. These aren't just incremental improvements. They're fundamental breakthroughs reshaping the very foundations of computer vision, from machines learning 3D understanding without scanners to AI agents that actively research visual content by browsing the web. Today's journey takes us through 6 dominant research themes that are reshaping computer vision fundamentals. We'll explore breakthrough findings that challenge traditional assumptions about AI capabilities, examine revolutionary methodologies enabling machines to see like humans, highlight 3 seminal papers that will influence the field for years to come, and discuss future directions pointing toward truly intelligent visual systems. This single day's research output reveals the accelerating pace of innovation in visual AI. Computer vision serves as the digital eyes of artificial intelligence, representing an interdisciplinary field that combines mathematics, physics, neuroscience, and cognitive science to teach machines how to see. This technology powers the autonomous vehicles navigating our streets, medical imaging systems, detecting diseases with superhuman accuracy, smartphone cameras recognizing faces and translating text in real time, and robotic systems performing delicate surgeries. The field has evolved dramatically from simple edge detection algorithms to sophisticated neural networks that understand complex scenes, often surpassing human biological limitations in specific visual tasks. The first major research theme focuses on breaking down traditional sensory silos through multimodal integration and understanding. Liang and colleagues demonstrate how AI agents can combine visual analysis with web-based information retrieval in their Video-BrowseComp benchmark. Meanwhile, Guang's team shows how fusing radar and camera data creates more robust perception systems for autonomous vehicles. This represents a fundamental shift from traditional approaches that treated different modalities as separate problems toward holistic perception systems that integrate multiple sensory inputs for richer understanding of the visual world. Foundation models and transfer learning emerge as the second transformative theme, reflecting the field's movement toward large, pre-trained models adapted for specialized tasks. Miao and colleagues exemplify this approach by leveraging the medical segment anything model for improved chest X-ray analysis. This methodology democratizes access to advanced computer vision capabilities by reducing the need to train models from scratch for each application. Instead, researchers can fine-tune powerful general-purpose models for specific domains, dramatically accelerating development and deployment of sophisticated visual AI systems. Self-supervised and semi-supervised learning represents the third breakthrough theme, addressing the persistent challenge of limited labeled data availability. Yamada's team achieves something remarkable, learning high-quality 3D representations from ordinary videos without requiring expensive 3D scanning equipment. Their LAM3C framework, trained on 50,000 scenes generated from room walkthrough videos, actually outperforms previous methods that relied on real 3D scans. This finding is revolutionary because it transforms the vast amount of video content already available online into a massive training resource for 3D understanding systems. The remaining 3 themes demonstrate the field's practical focus and specialization. Real-time processing advances, exemplified by Zhang's YOLO IOD framework, enable continuous learning without forgetting in live systems. Context-aware understanding, highlighted by Constantinescu's work, boosts object classification accuracy from 38% to 73% by considering spatial relationships. Finally, specialized domain applications span medical imaging, agriculture, and autonomous driving, with each domain driving innovation in core computer vision techniques while addressing unique industry-specific challenges. 5 revolutionary findings from these papers are fundamentally changing the field. First, high-quality 3D understanding can be achieved using ordinary internet videos rather than expensive scanning equipment. Second, context awareness dramatically improves performance, jumping accuracy from 38 to 73% while beating larger models. Third, even advanced systems like GPT 5.1 achieve only 15% accuracy on video research tasks, exposing critical gaps. Fourth, medical AI effectiveness depends heavily on specific task architecture combinations. Finally, AI systems can now continuously learn new objects without forgetting previously learned ones, enabling adaptive deployment. Modern computer vision research relies on 5 core methodological approaches. Transformer architectures, originally developed for natural language processing, use attention mechanisms to model relationships between different image regions. Contrastive learning techniques pull similar examples together in feature space while pushing dissimilar examples apart, enabling powerful self-supervised learning. Graph neural networks represent images as nodes and relationships, capturing complex relational information. Multi-scale feature fusion handles objects at different scales within the same image. Finally, pseudo-labeling and knowledge distillation allow models to learn from unlabeled data and teacher models, reducing annotation requirements. The Video-BrowseComp benchmark by Liang and colleagues stands out as the first evaluation framework testing AI systems' ability to actively research video content rather than passively perceive it. Their benchmark includes 210 carefully crafted questions requiring temporal visual evidence that cannot be answered through text search alone. The sobering results reveal that even GPT 5.1 with search capabilities achieves only 15% accuracy, largely relying on textual proxies rather than genuine video understanding. This work exposes a critical bottleneck in current AI systems and establishes a new evaluation paradigm for multimodal AI systems. Constantinescu's work on context-powered object recognition fundamentally challenges traditional approaches by explicitly modeling spatial relationships and material properties. Their framework constructs geo-semantic contextual graphs from single images, integrating metric depth estimation with unified panoptic and material segmentation. The results are striking. Their context-aware model achieves 73% classification accuracy, dramatically outperforming context-agnostic versions that achieve as low as 38%. Even more impressive, their structured approach surpasses fine-tuned ResNet models and state-of-the-art multimodal large language models, demonstrating that explicitly structured representations can beat end-to-end learned approaches. Yamada's breakthrough in learning 3D representations without 3D scans represents a paradigm shift in the field. Their LAM3C framework leverages room walkthrough videos commonly found in real estate listings, using noise-regularized WASs and multi-level clustering to preserve geometric relationships despite learning from reconstructed rather than directly scanned data. Remarkably, their approach outperforms previous methods that relied on expensive 3D scanning equipment, suggesting that the knowledge embedded in video data may be richer and more diverse than traditional 3D scanning datasets. This work democratizes 3D understanding by removing hardware barriers that previously limited access to advanced 3D computer vision capabilities. Looking toward the future, several key directions emerge from this research. The convergence of multimodal understanding and real-time processing capabilities is creating possibilities for AI systems that can actively explore the world through multiple sensory channels. The success of context-aware approaches suggests future systems must move beyond isolated object recognition towards holistic scene understanding. The democratization of advanced capabilities through clever use of available data is removing traditional barriers. However, significant challenges remain, including the integration of additional modalities like audio and haptic feedback, ensuring safety and robustness in critical applications, and bridging the gap between current AI capabilities and human-level visual understanding. This analysis was created through synthesis using GPT and Anthropic Claude SONNET-4-202505514. Models with TTS synthesis powered by DeepGram technology and image generation capabilities, provided by Grok AI system. The content has been reviewed by human experts for accuracy and coherence. While we strive for comprehensive coverage, potential oversights may exist despite our review process. All original research references are provided for further investigation. This methodology ensures both technical accuracy and accessibility for our diverse audience of researchers, practitioners, and technology enthusiasts. 3 key takeaways emerge from today's exploration. First, the power of context and structured reasoning cannot be overstated. Explicitly modeling spatial relationships dramatically improves performance, often surpassing larger, more complex models. Second, the democratization of advanced capabilities through clever use of readily available data is removing traditional barriers and making sophisticated computer vision accessible to broader applications. Third, the gap between passive perception and active understanding remains a critical frontier that represents one of the most important challenges ahead. The future belongs not to one-size-fits-all solutions, but to carefully designed systems leveraging domain knowledge and structural understanding. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprint-server.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprint-server.org.